Welcome to Chemistry in the PM. Lesson already in progress. We are recording live. And if you're watching, it is not live. It's recording. Anyways, we had begun this and we went over, this is for the people at the benefit of the recording. Something's organic, it has both carbon and hydrogen in the molecule. We verified that. You have to commit these prefixes to memory. Pause if you need, look at your notes. We're talking about alkanes, kynes, and kenes, double, single, and triple bonds. We went through the propene, and propane examples. But right now we're looking at pentene. We're looking for an alternate structure. Okay. Sorry I didn't start the recording. Okay. Now, pent means 5 in a row, and there's got to be another way to hitch these up. Now, you may say, well, what about if I put the double bond here? I'd say, yeah, that's the mirror image of what we have in green, the double bond there. So I'm not going to use that. That's not different. I'd just be able to pick it up and what about between the second and the third? That is actually structurally different. We'll put the double bond there. The rest, single bonds. I'm going to do 4 bonds per carbon, as we were doing before. 1, 2, 3, 4. 1, 2, 3, 4. Right now, for this part, later on it makes a difference, but I'm not worrying about whether the extra hydrogen was on the top or the bottom as far as the double bonds. And I attach my H's. Okay. Anything else is just a repeat or a mirror image of one of the blue or the greens. Okay? They're both correct, because I just said pentene, but underneath them you'll say they're called isomers. Same formula, but different structure. So we need a naming system that tells the green from the blue. So we've got to number the carbons so that we have the lowest possible number at the double bond. So I'll show you what I mean. I'm thinking, and I don't normally include this on here. I go 1, 2, 3, 4, 5. If I number it like this, the first carbon has the double bond, right? If I numbered it from right to left, in this case, between the 4th and the 5th, that's not the lowest possible. So you can number right to left, left to right. Whichever one gives you the lowest number at the double bond. Okay? So it's pretty obvious in that case, number 1, 2, 3, from left. In that case, not always. Exactly, and just to confirm, I'll just what you just said in this group. If I had, no, it's upside down C's, but if you had this, it would make sense to number it from right to left, because your first carbon is your double bond. Does that make sense? Always go with the number, don't automatically go left to right. In this case, number 1 on the right hand side. You'll see molecules sometimes drawn up and down, the bottom number 1, right? Okay. And in the other case, you can see it's between the second and the third. That's the lowest possible, not the, okay, not the other way around. Okay. So here's our naming system. I'm going to write them underneath. So for this one, we would call it 1. And I'm just going to put something. Pantene, not the shampoo. Pantene Proby. The other one, we're going to call it 2 because it starts at the lowest possible number 2. The 3 is assumed for the next. 2 and then that way, chemically, there's only one right answer for 2-pentene. For this one, though, I did in my mind, so 1, 2, 3, 4, 5, 5. It's these ones that are the second and the third. That's where the bond is, right? So you always give the lowest possible, not the 3, the 2 number in the name. Always have the number first. Okay, I got you. Don't say pentene dash 2. No, 2 dash pentene. Spot and then the name. Okay. Well, let's give this a whirl. Don't be shy. Give it a try. Well, you guys work these out. Okay, the first one, poutine. Poutine. No, butane. 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 Okay, pronunciation. Okay, so you use the proper prefix and the proper ending, and if it's required, this one there's no choice for the second one. There's no choice for the triple bond. It's only on the first carbon, right? We'll go through them. So, well, we'll go through this group. Okay, there's 1, 2, 3, 4 carbons. Always count your number of carbons first. So then which prefix means number 4? Bute. And it's all single bonds. The ending is A, E, or Y, any. A-N. Bute, N. You guys follow the logic there? That's what we're doing. Butane. Happiest country on earth is Bhutan. Different place. There you go. Happiest country on earth is Canada. Let's get real. Okay. This second one. First, you figure out the prefix. 1, 2. So what is the prefix? S. E-T. H. And because it is a triple bond, Y-N-E. Now, do you need a number? There's no choice where to put the triple bond. It's only attached to the first carbon. So it's actually incorrect to say 1 SI. You just say SI. Okay? These numbers will only occur after you get to bute or higher, or butene. So number 3, I have written 2 different ways. I have it written in green here as an abbreviated kind of way, short form, because you can see that once you get going like with a lot, well, there's what? 1, 2, 3, 4, 5, 6. There's hex. And I've got 1, 2, 3, 4, 5, 6. It's the same molecule. You see how I've abbreviated it? Well, the CH3 here, might as well just call it CH3. We know how they're, because carbon's pretty predictable how it bonds, right? So it's just repetitive. And then CH2, CH2, CH, double bond, CH. That's where this comes from. So you're going to get used to seeing it in the abbreviated form. But the thing is, how many were there? 1, 2, 3, 4, 5, 6. So what's the prefix? 6, and it's hex. Hex, and then because there's a double bond, E-N-E, hex-E. And because there's more than one spot that this double bond could have been. It could have been on the first carbon. Nope, it isn't. So we have to say the lowest possible number to that double bond is from right to left. What is it? What's the number? 2. I'm numbering actually this way. 2. So we're going to say 2. Oh, I'll be darned. Hex-ene. right to the left. Now this last one, initially, if I gave it a C7H16, you'd have to figure it out. But I have it drawn out. 1, 2, 3, 4, 5, 6, 7. All three of these ways give you the same information. What's the name? The hept. And then aim. It's all single bonds. If you notice in the green there, there's nothing with double bonds. Okay. Heptane. So we're good with this? Okay, let's do it the other way around. I give you the name. Okay. Methane. What about a picture of a cow there? Where's methane source? Cow farts are a big source of animals in general. Yeah. There's methane in it. Draw the structure. Meth means how many carbons? How many bonds to a carbon? So there must be 4 hydrogens, right? CH4. We're strictly using Lewis structures, by the way, right now, okay? So there you go. So don't worry about 109 degrees and stuff like that. Just draw it four direction. I'm going to get you guys to try the heptines. 1 and 3 and the 1 and 3 heptines. Okay? So where you go. And I will pause the video and you guys will work. We'll take those up in a minute. I'll start to record. Welcome back. Hopefully you've had a chance. We've paused the video and we're now going to look at chemistry in the PM. Yeah. Cows. Okay, CH4 is what you should have for your methane, like that, right? Draw the diagram. Heptine. Look like this, right? It's kind of squishy, but. Okay, and then the hexine. Go, girl. Go, girl. Okay, and then lastly, the 3 hexine. All of these could have been done in the smaller abbreviated form too, by the way. Like, for example, there in blue. Whichever you like, I don't care. If you continue on in university and stuff like this, you'll experiment with some different methods. Okay? All right, I'm going to pause the video, get you to your next topic, and then we're pretty much done the course. Okay, so not everything's in a straight line always. So not everything will be in a straight line. So we need some rules when you got branches. Okay? And corner over there. So when we have branches, and I give an example of isobutane versus butane and stuff, but the branches make sense because they use the same prefixes, meth, eth, prop, and stuff like this. We won't have things bigger than butyl groups that are attached to a main long chain. So this is just the chart for reference reasons. Now, I don't think you guys have this part here. So we'll figure this out. Something like isobutane. Now, I have it here circled for you and stuff like this. If you take a look at this, I call it the parent chain because it's the longest possible. There's 3 carbons in a row. You can't get longer than that, right? So we're going to call it a prop group, propane, with an attachment of 1 carbon-hydrogen combination after that. That's the methyl group. How would we say what this is? How would we name it? Well, we have to say where it's from. So we know we have propane. I kind of do the names backwards, okay? As in, using the rules, propane. Then I'm going to write on the left-hand side, what's attached to the propane? It's a methyl group. And then the methyl group, where is it attached? It's attached to the 2nd carbon in the propane. So, like I said, I tend to do the naming backwards. You have to plan those to leave enough space to do it. Propane is the parent chain, the longest possible chain. Methyl group is the attachment, and it's in the 2nd carbon of the propane. So that's the way we go about naming. We'll practice. Okay? Now, according to the rules, if you have substituents, attachments, they're listed in alphabetical order. So if you had ethyl groups and methyl groups in the same thing, you put ethyl first because E becomes before methyl. And you use di, tri, and tetra if you repeat. Di would mean dimethyl groups. There's 2 methyl groups. Tri, 3 methyl groups, and so on. Okay? So, according to this, what do we got here? Well, I suggest naming it backwards. So, what's your longest chain? I have it numbered on here. 6 in a row, right? I am recording that. Yep, I know. Okay, so 6 in a row. So what's the name of my parent chain, the longest chain possible? 6. Hexane. And to keep things simple, I'm not going to have chains that have double or triple bonds in them. It's not that complicated. I'm just going to keep things simple. So hexane. Then, what are the attachments? What kind of groups? Methyl groups. So I'm going to put that ahead of here. And there's 2 methyls, so I'm going to say dimethyl. Where are the 2 methyl groups located? On the 2nd and the 4th carbon, right? So we're going to put 2, 4 dimethyl hexane. It's kind of logical. I think it's been all right around this table. Oh, you started with it. Fair enough. Okay, I'm fine with that. So are we good at this? Yeah, wow. It has to go in this order. The parent chain has to be the last. Hexane has to be the last. So try out this. Now have it in both ways. Pretty good. Up above. Thanks. Okay. Okay. What's the longest possible chain we've got here? Oh, in that question. Not forever. IUPAC means the international naming rules like science. Don't worry about it. It's the official rules. Okay. UPAC rules. Okay, always take a look. The straightest line, straight from left to right isn't always the longest. It is in this case, but it isn't always. Because you could consider this as your, but that's actually the same line as just going, I'll let this evaporate. Okay, so always take a look though. It might not be from left to right. It is in this case. This is your longest chain. It could take an angle, turn. Sometimes you have to see. You'll see that on the next list. But In this particular case, it is from left to right. There's 5 carbons in a row. That's the longest chain you can find, right? So I'm going to just circle that so we know. Okay. I've got 5 in a row, so that's pent. Okay. What kind of attachments? I have methyls all the time. There's 3 of them. So trimethyl. Trimethyl, and I have to say the location. And I have to give it the smallest possible numbers. If I labeled it from right to left, I would have 2, 4, 4. I can get smaller numbers if I go from left to right, though. I go 2, 2, 4. So as in, this one's on the second, this one's on the second, this one's on the 4th carbon. That's the way I'm going to number it. You have to say where these 3 methyl, the trimethyl groups are attached. They're attached to the second, also attached to the second, and the 4th carbon. Yes, but for this particular one. And you will see. Now, this particular one, I'm just going to undo this. Okay, for this last one, the way I gave it to you, you might not see the longest chain right away. So I'm going to look at the red one. I actually find when it gets too complicated with the way I did it in blue, with the CHs where the H's are all separate. I see it easier if I see it in red. The CH3 groups and stuff like that. Okay? So if I count from left to right here, I've got 1, 2, 3, 4, 5, 6, 7, 8. That's not my longest possible chain, though, is it? If I count, starting here, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. See how that's longer? So you're going to go with this as your longest chain. In other words, on this blue diagram, yeah, it could be zigzaggy. Yeah. So you see how I have 9 in a row with what I've circled? Either system of the diagram, I know I'm going with non-in. I have no name, but not no name. Non-in. Okay. Now I want to say your name again because I want to get it correct again. I surprised myself when I said that. Okay. Now, the attachments in this case are all methyls again. So which way will we number it? We give the smallest constant. So if I think of it as 1, 2, 3, 4, 5, 6, 7, 8. Okay, I have a 3, 6, 8. If I numbered it the other way, 3, 6, 8. I go 1, 2, 3, 4. You have to say where the attachments are. And we want to use the smallest possible number. Okay. I got sidetracked there though. 1, 2, 3, 4, 5, 6, 7. So it's attached to the 7th carbon. So that direction, if I label it, I have smaller numbers. I'm going to go with 247. Primary. 247. Try that. Non. Do the chain first. I'll give you a mark for that. Then any attachments, I'll give you the other one. 247 try. I'll be a little forgiving if you have 3, whatever it is. But, okay. So the last bit. I went this way because it gives me swelling. 4. Yeah. So the 7th one is attached there. That's the way I thought it. And in the last 6, 7 minutes, I'd like you to try these questions. I left the names on here, but I mean, just a second. There we go. So, you come up with the names. And then you name the following. Okay, that's what I'm leaving with you. And we will call it. Let me just pause the video.